7.1 Oblique triangles and the law of sines. So this entire time we've been working with right triangles. Oblique triangles are just the opposite. They're not right triangles. Alright, some things you might remember from geometry way back in the day. Side angle side. If two sides and the included angle of one triangle are equal, respectively, to two sides and the included angle of a second triangle, the triangles are congruent. Angle side angle, if two angles and the included side of one triangle are equal respectively to two angles and the included side of a second triangle, then the triangles are congruent. Side side side, if three sides of one triangle are equal respectively to three sides of the second triangle, then the triangles are congruent. So that's just how you can use congruence. Axioms are basically kind of like rules. I apologize if you can hear my dishwasher. I have to record this in my kitchen. Alright, oblique triangles. So, oblique triangle, a triangle that is not a right triangle. The measures of the three sides and the three angles of a triangle can be found if at least one side and the other two measures are known. So data required for solving oblique triangles. So each case, you need to actually have your information fall under a case to even be able to solve it. So with what you have, if it doesn't fall under case 1, 2, 3, or 4, you cannot solve that triangle. So case 1, one side and two angles are known. So if you have one side and two angles, you can solve that triangle. And remember, solving a triangle is finding out everything about it. So that's called angle side angle or side angle angle. So case 2, two sides and one angle not included. Between two sides are known, so side side angle again. So you have two sides and one angle. This case may lead to more than one triangle, and we will talk about that. Two sides and the angle included between the two sides are known, and three sides are known. If we know three angles of a triangle, we cannot find unique side lengths, since AAA assures us only similarity, not congruence. So basically, you need a side. If you don't have a side, you're not going to be able to solve the triangle. Alright, law of sines. So we have sides ABC. All these three equal, that means you can set A equal to C, B equal to C, any of them. You can set any of the two equal to each other. Alright, applying the law of sines. Let's solve triangle ABC if A is 32.0 degrees, C is 81.8 degrees, and side A is 42.9 centimeters. So we're given two sides and an angle, we can solve this. Because if we're given two sides and one angle, that's actually case 2. Alrighty. So we need to know what we need to find. So we need to find angle B, side B, and side C to complete this triangle. That's what's missing. So the first thing that you want to do, if you're missing an angle and you have two of them, find that missing angle, because we're given two angles. Let's find B, and we can find that by subtracting 180. So we have angle B equals 180 minus 32 degrees minus 81.8 degrees. And when we do that, we get 66.2 degrees. Awesome. Now that we've had angle B, we can go ahead and find side B and side C. So I found side C first. Just wanted to. So side C. So side C, that's this one right here, because that is our side C. So we know that we're going to be using C over sine C. And that equals, use what you're given. So you see here how we're given angle A and side A. That's what we're going to use throughout this problem. You always want to use as much as you can what's given to you. So we're going to equal it to A over sine A. So let's go ahead and use our formula. We don't know what C is, we're trying to find it. Over sine angle C. We know what angle C is. it's 81.8 degrees. And that equals side A, which we do know what it is, it's 42.9, over sine A, which is 32.0 degrees. We can just put 32 degrees. Alright, now since this is just one fraction on each side, we can cross multiply here. So when we cross multiply, we are left with C sine 32 degrees equals 42.9 sine 81.8 degrees. And then still solve for C, so we're going to divide by sine 32. And we need to plug this into our calculator now. So I'll actually show you how to do that. I'll show you both ways, if you have a newer calculator or if you have an older calculator. Alright, so what we need to plug in, if you have a newer calculator, you can totally do this. Hit alpha y equals enter, and then you're going to type in what you have. What mode should we be in? Degrees, because we're working with degrees. Yours is probably already on degrees, but mine is not because it gets reset every time. So now I'm trying to get to degrees. There we go. Alright, so in our fraction on top, we have 42.9 sine 66.2. I mean, my bad, 81.8. And then that's over sine 32. And we get our approximate answer of 80.12805567. So I'm going to write down that. So I'll put in here degree mode. So in degree mode, when we plugged that in, we got approximately 80.128005567, and we round to the significant digits. So see 81.8. How many significant digits do we have? 3. So we can round this to 80.1 degrees. Awesome. We found C. It is 80.1 degrees. Before we move on to finding the last side, you are not allowed to use the Pythagorean theorem. Why? Because this is not a right triangle. Remember, Pythagorean theorem is only for right triangles. So right now, the only thing you know of for non-right triangles, also known as oblique triangles, is law of sines. You can also find angles if you flip it. So see here how we have sine, the orange one's C over sine C. You can flip it to have sine C over C. So you can actually find your angles if you flip them. But if we flipped it, we would have to make sure it would be sine A over A. Okay. Alrighty, let's go ahead and find our last side. Side B. Do it in blue. So since we're trying to find side B, we're going to be using B over sine B. Use what's given. So you see here how we used A over sine A? We're going to use it again. So let's go ahead and plug in what we have. We're trying to find B. And that's over sine B. So sine B is 66.2. And that equals A over sine A. So same values we had before. We had 42.9 over sine 32 degrees. So see here for sine B, we had to use what we found. That's okay because we absolutely had to use it. But you always want to try and use as many values as they give you to find the answer because it'll be more exact. Again, we cross multiply. So when we do, we have B sine 32 degrees equals 42.9 sine 66.2. We're going to divide. I'll show you once more how to plug this into your calculator. I'm going to show you the older calculator way. So we get B is approximately, let's go ahead and plug it in. Alright, so if you have a new calculator, just alpha y equals enter, but if you have an older calculator, it might be harder to plug in, so we're going to do it piece by piece. So if you have an older calculator, we have 42.9 sine 66.2. Press enter, and then we need to divide that by, since we have something big in the denominator or multiple things, wrap your denominator in parentheses, and it's sine 32 degrees. And we get 74.07 degrees, and we'll round that eventually. So if you have a fancy new calculator, remember you just hit alpha y equals, alpha y equals enter, and there's your fraction bar, and just exactly type in what you have on your piece of paper. Okay. Alright, so when we plugged it in, we got approximately 74.071222632, and we're going to round that using our significant digits of 74.1 degrees. So we found B at 74.1 degrees. And those are our answers. Sweet. Alright, whenever possible, and I'm going to say it again, use the given values in solving triangles rather than values obtained in intermediate steps. So intermediate steps are, you know how we found angle B, or we approximated side C? Those are intermediate steps. You don't want to use them because you don't want to run into rounding errors. So you know how we rounded 74.0712263? We rounded it to 74.1. So that would actually give us a slightly different answer if we would have used the rounded version of that angle. Alright, Martin wishes to measure the distance across the Colorado River. He determines that angle C is 112.90 degrees, angle A is 31.10 degrees, and side B is 347.6 feet. Find the distance A across from the river. So if it's a capital letter, it's always an angle, and it's degrees. If it's a lowercase letter, it's always a side. Alright, so we're trying to find is the distance A across the river. We're trying to find this one right here. How far is that? So we're trying to find side A. That means we're going to have side A over sine A. Let's see what we're given. We're given A, sine A, so we're given that. Awesome. Let's see, what else are we given? We're given side B. So since we're given another side, we're absolutely going to be using that side. So we're going to use B over, change colors here, sine B. So we need to find angle B. We need to find angle B. Also, how you know you need to find angle B? Usually, you always need to find that missing angle if you're given two angles. So you see how we're given two angles? Find the missing angle. Alright, so let's go ahead and do that. Let's find angle B. We have 180 minus 112.90 minus 31.10, and we get 36 degrees. Cool. Now we can actually work out this problem. We have A over sine A. Sine A is 31.10. And that equals side B, which we do have. It's 347.6 feet, over sine B, which is 36 degrees. We cross multiply. And when we do, we get A sine 36 degrees equals 347.6 sine 31.10, plug that into your calculator, or excuse me, divide, and then plug it into your calculator, getting ahead of myself. So we divide by sine 36. And when you do, you get A is approximately 305.463576. So we're going to round that with our significant digits. We have how many significant digits? 1, 2, 3, 4. Remember, we don't count the zeros at the end. You could also hear 1, 2, 3, 4. So 4 significant digits, it would be 305.5 feet, because that's a 6, so we round up. So the distance across the Colorado River from where this dude is standing is about 305 feet. Alrighty. 2 ranger stations are on east-west line, 110 miles apart. A forest fire is located on bearing north 42 degrees east from the western station at A and a bearing of north 15 degrees east from the eastern station at B. To the nearest 10 miles, how far is the fire from the western station? So how far is the fire from the western station? What we're actually trying to find is this side right here. Because that's the west station, that's the east station. Remember, never eat shredded wheat. So that's the west, that's the east. And it labeled everything for us, but I'm going to walk you through labeling it so we can go over that together. So it says that a forest fire is located on a bearing of northeast 42 degrees. That's why this is 42 degrees, because a bearing, remember, it's not this angle, it's the angle that's connected to that north direction. Then it says from the western station at A and a bearing of north 15 degrees east. So that's why our eastern station has our 15 degrees right here from the bearing. The bearing is from the north, right here, okay? And then we're given the distance between the stations, which is 110 miles. So we're trying to find B. That's what we're trying to find. So we obviously know we're going to have B over sine B. So I have to figure out what else we can use. So let's see what else that we're given via distance. We're given side C. So since we're given side C, we're going to be using side C. That means we need to find angle C. So we need to find angle C. The reason why we used C is because directly across from the angle, we have a distance. That means that's side C. Okay, so we need to figure out everything inside the triangle to find C. So let's go ahead and find this angle right here. That's not angle A, it's angle BAC. So BAC. So angle BAC, we can find that by doing 90 minus 42. Because this is complementary right here. It's a right angle. Since that's a right angle, we can go ahead and find what creates that right angle. And it is 48 degrees. So we found this, it's 48 degrees. Awesome. Now we need to find angle B. So we need to find, I'm running out of colors here, we need to find this angle right here. So this angle right here, that whole thing is 90 degrees. So we need to add 90 to it, to the 15, to figure out what that whole angle is, the whole angle. So angle B is 90 degrees plus 15 degrees, and that's 105 degrees. So that means this whole angle right here is 105 degrees. Now we can find angle C. We can find angle C because it's 180 minus what's inside the triangle. So angle C my bad, pink. Angle C equals 180 minus 48 minus 105. And we get angle C is 27 degrees. Cool. Now we have it. Let's plug everything in. So side B is exactly what we're trying to find over sine B. So sine B, our B angle is 105. And that equals C, side C, which is 110 degrees right here. 110 miles, my bad. Over sine C, which is 27 degrees. We cross multiply. So we have B times sine 27 degrees equals 110 sine 105 degrees. We divide by sine 27. And when we do, we get B is approximately 234.0. Not bad. Let me rewrite that. 234.0397893, which is approximately 230 miles. It asked us to round to the nearest 10 miles. So 10 is 200 miles, 210 miles, 220 miles, 230 miles, 240 miles. So we rounded it to the nearest 10 miles, which is 230 miles. All right. Your whole life, maybe, it depends on what math you've taken in high school, you've been finding area of a right triangle. Now we're going to find area of an oblique triangle. So we can find area of an oblique triangle given a side, angle, and a side. So depending on what you're given, you can use either formula. Note, if included angle measures 90, its sine equals 1, and the formula becomes the familiar area equals 1/2 base times height. Alright, let's go ahead and figure out what we're given, find the area in example 4. So we're given angle B. Okay. So we're given angle B, which is 55 degrees, 10 minutes. We're given side A, because across from angle A is side A, which is 34 feet. And then we're given side C, because opposite C is 42 feet. So let's see, from what we're given angle B, and we have side A and side C. So the formula we're going to be using is area equals, my bad, it's a fancy A. They're going to write it like this. Area equals 1/2 AC sine B. All right, let's plug it in. We have 1/2 A, which is 34. C, which is 42. And sine B, which is 55 degrees, 10 minutes. So I'm going to actually show you how to plug this into your calculator. Alrighty. Pull out my calculator. Oh, we have the fraction bar already going. Awesome. You actually don't need it because you know 1/2 is 0.5. So 0.5 times 34 times 42. And then sine 55 degrees, so second apps is how you get the degree. And then 10 minutes, so 1, 0. We get the minutes by saying second apps, and it's number 2. And we get 586.06333683. So we get area, my bad. Area is approximately 586.0633683. So area is approximately 586 feet. 3 significant digits, so that's why we rounded to 3 significant digits. Squared, my bad. This area is squared. Alright, last example. Alright, let's see what we're given. We're given angle A. We're given angle C. And we're given side B. Alrighty, so we need to find area. That means we need 2 sides. So we're missing a side. Anytime you're missing a side and you have 2 angles, find the missing angle. So you see how we're given 2 angles? Find the missing angle. So we can find angle B by doing 180 minus 2440 minus 5240. And we get angle B equals, where are you? If you use your calculator, this is what they're going to give you. But that's not what we're working with. So with your calculator, if you want to get to minutes, you press second, apps, and hit number 4. Looks like this. And you'll get to it. And you should get B is approximately 102.40. All right. So now we have all our angles in one side. We need to find another side. We're actually going to find, you could use A, you could use C, it doesn't matter here. This is where we can start to do different things. I'm going to find A. So let's find side A. So we have side A over sine A. And that equals, what we have is B. We have all of B, so we're going to use B. So B is, our side B is 27.3. And we have sine B, which is 102.40. We cross multiply. And when we do, we have A sine 102.40 degrees equals 27.3 sine 24 degrees 40 minutes. We divide. And when we do, we get A is approximately, my bad, that is right. A is approximately 11.67754462. So we would say 11.7, 3 significant digits. Alright, now we have 2 sides and 3 angles. So since we have 2 sides and an angle, we can go ahead and find our area. So we have side A and side B. Since we have side A and side B, we're going to be using this formula right here because we have A, B, and we have angle C. So we're going to be using area equals 1/2 AB sine C. So we have area equals 1/2 side A, which is 11.7, side B, which is 27.3, and then sine C. So sine C is 52.40. Plug that into your handy dandy calculator and you get area is approximately 126.9847668. So we're going to round to 3 significant digits. So area is approximately 127 centimeters squared.